Okay, so let's talk about Riesz Thorin theorem. Okay, so let P not equal to P1 and Q not different of Q1, okay, and T is a bounded operator that goes from LP not X to LQ not Y, okay, and the norm T in this case it will be equal to M naught. Okay, this will be and goes to from P naught to Q naught. Okay, and then also T we go from LP1X to LQ1Y, and again now the norm of T will be equal to M1, and T in this case will be P1, Q1 the norm, okay? So then T is going to be bounded from LP theta X LQ theta Y, and the norm in this case will be M theta. Now we will say what it is that this is P theta Q theta, okay. M theta will be less than equal than M naught 1 minus theta M1 theta with 1 over P theta equals 1 minus theta over P naught plus theta over P1, and 1 over Q theta will be equal to 1 minus theta over Q naught plus theta Q1 with theta between in open interval 0, 1. So a remark is that if theta is 0, it will be gone, and so we will have that P naught is P theta, and if theta is 1, then this will be gone, and then you will have that P theta is P1, okay? The same will happen here with Q theta, Q naught, and Q1. So this we can say that this is like a convex description of the spaces between um, P naught and P1 and Q naught and Q1. Okay, so let's prove this. Recall that the scalar product between h and j, two functions, uh, it will be the integral of hy gy dy, okay, and um, uh, we can say that norm of hq, okay, it will be the supremum of the absolute value of the scalar product of h and j, such that norm of g q prime will be equal to 1, okay, and let's say m pq will be the supremum of the absolute value of the scalar product tfg of the norm p norm g q prime equal to 1, okay, and we are always saying that 1 over p plus 1 over p prime is equal to 1 over q plus 1 over q prime, and all equal to 1, okay. Okay, so let's define fx equals to aj g aj x, okay, simple functions, and g of y j, no, this is k, this is j, and this is k, bk bk y, okay, so these are just um, simple functions. Recall that this type of functions are dense in LP, okay, and we will say that the norm of f p will be equal to 1, and that the norm of g q prime is equal to 1, okay. Okay, and for real part of z between 0 and 1, we'll find 1 over pz equal to 1 minus z p naught plus z over p1, and 1 over q prime z equals 1 minus z q naught prime plus z q prime 1, okay. So p, as I said before, p is 0, v equals p naught, p theta will be p, and p1 will be p of 1 will be p1, okay, and this, the same thing will happen with q prime. This is p theta we defined as this one is theta between 0 and 1, the open interval. Okay, so now we define 5z equals to the sum j, absolute value j, p theta over pz, p of z, okay, e I arg aj, and then the characteristical function, and psi z will be the same, defined in the same way, but with q prime, okay, ei arg ek psi ek y, okay. So these two functions are going to be integrable step functions, and so we will have that phi z will be in L p j, and psi z will be in L q prime j, okay, j, and the same, for the same reasons, we had that t of 5z will be in LQJ. We're always talking about integrable step functions. Being transformable happens the same, okay, and we're always here talking about j 0 or 1. Okay, so LP0, LP0, LP1, LQ prime 1, Q prime 0. Okay, and recall that theta was going between those numbers. And the same will happen for phi prime of z, psi prime of z, and t of phi prime of z. Okay, and so if we define the function fz equals to scalar product of t5 z psi z, then this will be an integral t5 psi. Okay, then we can say that f is bounded and continues, okay, on a real part of z between 0 and 1, and analytic in the interior. Okay. Moreover, we can say that the norm of phi of it, norm p naught, and it is in this set, but is in the boundary of this set. Okay, and if we recall what it is, phi of z, then we will have that this will be equal to the norm of f p theta over p naught. Okay, because we have j equal to 0. Okay, so if changing with the definition of this norm, we can say also that this is the norm of f of p theta p naught. Okay, and this will be equal to 1, as we already said before, because this is a simple function. We can say exactly the same for phi and the norm of phi 1 plus 1 it, okay, but in the norm of p1, and 1 plus it will be also in the other boundary of this set. So this will be equal to 1. In the same way, we can say that psi of it, norm q prime naught, will be equal to the norm of phi of 1 plus it, okay, and norm q prime 1, this will be equal to 1. Okay, so from the hypothesis we know that f of it absolute value will be less than equal than the norm of t phi it q naught multiplied by psi it q prime naught. It will be less than equal than m naught. And then in the same way, the norm of f of 1 plus it will be less than equal than m1. Okay, so as we know that phi of theta is equal to f and psi of theta is equal to g, then f of theta is equal to the scalar product of tf and g. Then by the three-line theorem we got that absolute value of t of f g will be less than equal than m0 1 minus. That is what we wanted to know. T is bounded by this